So now let's see the next CPU scheduling algorithm, which is this round robin algorithm. Okay, so this is one of the most popular algorithm in most of the real world scenarios. This round robin algorithm is chosen. Okay, so after learning this algorithm, you will be understanding the beauty of this algorithm. So this is the preemptive version of first come first serve CPU scheduling. All right, why so? I will explain. So there is something called time quantum. So every operating system who is using this round robin algorithm, okay, will be having some value like time quantum. So what this time quantum value says? So this says the maximum continuous time duration a process runs. Okay. So after that, forcefully that process is preempted. Okay, and this is done by operating system. So let's say for a process, the burst time is 5 unit. Okay, and the time quantum value for the operating system is 2 unit. So after execution of 2 unit, this process P1 will be forcefully preempted and another process will be scheduled. Okay, maybe process 2 or process 3. And then this process P1 will be pushed into the ready queue again with the remaining burst time as 3. So with example, it will be much more clear. Operating system does not allow any process to hold the CPU for continuous time, okay, which is more than time quantum. So that is what I have explained. So with examples, you will be understanding it much more better way. Alright. So this is a modification of first come first serve algorithm that you can say. Okay. So when there are multiple processes, okay, that are waiting for CPU, it gives fair chance to all the processes. This is one of the most important advantages of this round robin algorithm. All right. So if I try to relate this algorithm with some real world scenario, so that is, let's say this is your hostel canteen. There is a chef who has prepared dosa. Okay. Let's say this is Sunday morning. All right. Fine. So let's say all the students are in the queue to take the dosa. So what will happen? The chef will be saying, I don't care how much hungry you are, but at a single shot, I'll be giving you at most 2 number of dosas. Okay. Even if after eating 2 dosas, your hunger is not finished, you come and again stand on the queue. Something like this. Alright. So the chef says, I will give max 2 dosas. Okay. So this 2 dosa is the time quantum to the person standing in front of the queue. Okay, it doesn't matter how much hungry that person is, only 2 dosa will be allocated to this person. So if the person stays hungry, go again stand in the queue. All right, so this is what this round robin algorithm is. So even though this algorithm is a preemptive algorithm, okay, your operating system does not look for new process at every unit of time. So what it does, okay, what it does is operating system looks for new process when time quantum is over, that means time quantum is expired, or the process is done with the execution. All right. So what it means? So let's say there is a process P1 which burst time is 10 unit. All right. But the time quantum is 2 unit. So after 2 unit of time, your operating system will be checking for new process. Okay. Not every unit of time. Or one more thing, let's say process 2 is having burst time as 5 unit and time quantum is 10 unit. So what will happen? In the single time quantum window, after 5 unit of time, this process P2 is over. Then 5 more unit of time is there. So instead of wasting this time, okay, your operating system will be scheduling one more process here. So either the time quantum expires or the burst time of the process finished. Whatever comes early, then your operating system starts finding a new process. Alright. So let's go to the detail part. Let's say time quantum is 10 seconds, okay, and the process requires 7 seconds of time. So operating system does not keep the CPU idle for the last 3 seconds. Okay, why last 3 seconds? So this is 10 and this is 7. Okay, this is 10 second, this is 7 second. Even though time quantum expires here at 10 second, but the process is done at time t equal to 7 second. So these 3 second, your operating system will not be keeping your CPU idle. All right. As soon as process is done with execution, operating system will schedule new processes. So let me tell you some pros and cons of this round robin algorithm. So the first point is fair CPU allocation. Okay. So what will happen is when your operating system picks a process to run, every time it will be running a fixed amount of time. Let's say time quantum is 2 seconds. So whenever a CPU is picking a process, it will be running that process for the next 2 seconds of time. Okay. Even if that process is requiring 10 seconds, your CPU does not care that. Your CPU will execute for the 2 seconds and will ask that process, hey process, you are done with the time quantum, now again go and wait for your next turn, something like this. So this is a fair CPU allocation. So very good response time. Okay. So response time is much more higher. Why response time is much more higher? Because there is no starvation and there is no convoy effect. Alright. So why no starvation and no convoy effect? Because there is a fair CPU allocation. Alright. So this is easy to implement and it does not need the burst time beforehand. Just like a shortest job first and shortest remaining time first, we do not need the burst time before starting the algorithm. Okay. So let me show you the disadvantages. Alright. So depending on the time quantum value, this round robin algorithm will change its behavior. When the time quantum value is too much high, then this algorithm will be behaving just like a first come first serve algorithm. So when this time quantum value is too low, so then there will be too many context switches which will be affecting the performance. Alright. And one more thing is it does not prioritize any process. I have already told you this is some modification of first come first serve algorithm. So whatever the order in which the process is arriving in the system, okay, round robin algorithm follows that order itself. We do not have any procedure in which we can prioritize and say, hey operating system, already you are running process P1, that is fine, but now process P10 has come, which is having much more higher priority. Please schedule P10. We cannot make any such demands. Okay, this is one of the disadvantages.